Okay, so for question 9, we're asked to find the average rate of change, or AROC, for the following functions over the given intervals. So for part A, we're given a quadratic function for f of x, and we're finding the AROC from x equals -2 to x equals +4. Now, in order to find the average rate of change, we're essentially just going to be looking for the change in the outputs divided by the change in the inputs. But the thing is we don't have the output values yet. And that's where using the function, and I'm going to use function notation for this, it becomes very helpful. So the other thing to remember here is that we're going from -2 to +4. So -2 is the beginning value and +4 is the ending value. So that is important that we find the rate of change, in that order, so to speak, on the number line. So the first thing we'll need to do is figure out, well, what is f of 4? I don't know the output value that is associated with 4. So we'll plug 4 into the function to figure that out. Similarly, I don't know what the output value is at -2. We can use the function to find that, of course. And once I have those two values, then I can subtract them to get the change in the outputs. Similarly, for the change in the inputs on the bottom, again, we're going from -2 to 4. So this is our beginning value and this is our ending value. And so the change does need to go from there to there. So that's a +6 units. But how you calculate +6 units is technically 4 minus the -2. So if we figure out the output values at those two function values, input values, so -2x squared plus 5x, so -2, but now I'm going to plug in x squared minus 5x, but I'm plugging in 4, and I believe it was -1. Let me fact check that. Oh, plus 5x. Did I have that? Nope. Let's fix that. Plus 5x, and then -1. Okay, there we go. So the function value at 4 is -13. So that's going to be this first numerator value is at -13 for the output minus whatever the function value is at -2. So function value at -2, function value at -2 is -19. Okay. And I want the difference in those values divided by, again, I mentioned this earlier, but since we're going from -2 to +4, we can tell that that's 6 units forward on the number line. But technically, how do you get 6 units? It's that ending value minus your reference point. So 4 minus -2 is indeed +6. So on the numerator here, we do have essentially a double negative, so it's -13 plus 19, which is just 6 over 6. So the AROC is 1. All right, that is the average rate of change for part A. For part B, we have a new function value. So same thing, I need to figure out the function value, the output value at the ending point, which is 19, minus the function value at the beginning or reference point, which is 8. And again, you can think about it, if you're going from 8 to 19, I know in my brain that that's 11 units forward. But technically, how do we get 11 units? It's because you have to take that ending value minus your initial or reference value. So 19 minus 8. So t minus 4 plus 1. So we have the square root of t minus 4, and then make sure you tap out of the radical to say plus 1. So the function value at 19 is going to be 4.87. We'll just round that. Oops. 4.87. So 4.87. And then the same function value at 8. So input value of 8 is 3. So 4.87 minus 3 all over 19 minus 8, like we said before, was 11. So 4.87 minus 3 is 1.87 over divided by 11. And we can get an approximation for that. 1.87 divided by 11 is 0.17. So the AROC for this one is 0.17. Okay, done and done. Last but not least, finding the AROC from x equals 3 to x equals 7, and this time we're given a graph. So when you're looking at the graph here, an x value of 3 is right here. But again, we're going to need the function value at 3. And again, we're going from 3 to 7. So let's just see. If I go to an input of 3 and see what the actual function value is, I get -9. So there's the starting point. And then I'm ending at 7, an input of 7. So input of 7, follow it up. Function value looks like it's 3. So those are essentially the 2 points that we're working with.
I found this on the
Now,
web.
whoa, no, I don't need you, Siri. Go away.
Okay.
Did you hear that? Okay. Siri says, okay. So what we have here are really two ordered pairs. Let's do this a couple different ways. So we now know that 3 pairs with -9. We also know that 7 pairs with 3. The other way we could think about this is f of 3 is -9 and f of 7 is 3. So that's the ordered pair, but also the function notation way of writing this. But again, the rate of change, the average rate of change that we're looking for is from that x value of 3 to the x value of 7. See, I can look at that hypothetical linear trend right there. If the rate of change was constant, average rate of change assumes that it stays constant. And I can tell that I'm going to need a positive or increasing rate of change to get me from point A to point B. But how do you calculate that? You have to take that ending value and subtract the reference or initial value. So this is where the order does matter when you're going from point A to point B. So 7 minus 3. Because again, I can tell by looking at this that it's 4 units forward. I know that. From 3 to 7 is 4 units forward. But technically, how do you calculate that? Well, it has to be 7 minus 3. Okay, so like we said, it's 4 units forward. And then our previous work reminded us that when you input 7 for x, you get 3 for the output. And when you input 3 for x, you get -9 as the output. So 3 minus -9, that's technically plus. So 3 plus 9 is 12. And 12 over 4 is 3. Now notice that rate of change is indeed positive, just like we predicted. Because again, from 3 to 7, that would be an increasing hypothetical constant trend. So that is our average rate of change. Okay, hopefully that helped. And let us know if you have any questions. Thank you.